Okay, batch. Today we're going to be looking at linear inequalities. So this is section 1C. So our learning intention today, we are learning about our linear inequalities. Our success criteria are: I can interpret number lines to write inequalities, I can solve linear inequalities and graph the solution on a number line, and I can show correct working out. Our meta language in our vocab. So an inequality is a relationship between two expressions or values that are not equal, indicating that one side is greater than, less than, or not equal to the other. And you'll see us get to that shortly. Okay, so here's our main ideas. So we have four inequality symbols. Okay, so we have our less than inequality, okay, our less than or equal to inequality sign because we've got that other line underneath it, our greater than, and our greater than or equal to, because we've got that line underneath as well. Okay, and visually we can see this on a number line here. So we have x is greater than a means that x is greater than some value a. So on a number line, we see we've got some value a here, and our arrow indicates that we are bigger than that value. Okay, x is greater than or equal to a means that x is greater than or equal to a. So we can include a. So here's that value a, and our arrow is indicating that we're bigger, but notice the difference here. This first one, we had a dot that wasn't colored in, and this one we have a dot that is colored in. So what we say is this one that's not colored in, we say is an open dot, and this one that is colored in is called a closed dot. So if it's a closed dot, we are including the value a. If it's an open dot, we're not including the value a. So we can be as close to a as we can get for this one, but not actually a. Okay? Similarly, when we look at our next one, x is less than a, that means we've got this value a again. Our arrow this time indicates that we're smaller than it. Our open dot means that we're not allowed to include a. Our next one is x is less than or equal to a. Right? Again, our arrow indicates that we're less than this value a. Our dot this time, though, is a closed dot, which means we are able to include that value a. Okay. Now we can actually combine some of these in this last little bit of key ideas here, where we're saying x is greater than a, but less than or equal to b. So basically we're going to be saying, like our picture shows here, that we're between these two values of a and b, but we are not allowed to include a, but are allowed to include the value b. Okay. And remember, a crocodile eats big things and poops out little things. So we have our greater than sign here. So this is our big side. So if we're on this, we're going to be greater than. Okay, and we've got obviously eating big things, pooping out small things. Easy way to remember it. Okay. Now we just spoke about our open and closed circles, so we covered that. Okay, when we solve linear inequalities, okay, our same rules as solving our equations hold, except we have one new rule. Okay, so if we multiply or divide by a negative number, we have to reverse the inequality sign. So for example, -5 is less than -3. Okay, that's equivalent to saying 5 is greater than 3, because if we multiplied -5 by -1, it becomes +5. And if we multiply -3 by -1, it becomes +3. And so we need to switch that inequality sign, otherwise it'd be around the wrong way. Okay. If we had something like -2x is less than 4, okay, and we want to work out what x is, well, what we need to do is divide by -2 to both sides, okay, and flip our inequality sign. Okay, so we reverse the inequality sign if the sides are if the sides are switched. So if I say that 2 is greater than or equal to x, remember our convention is that when we're doing our equations, is our final answer will be x equals something. Okay, well, same thing with our inequalities. We want to write it as x is less than something or greater than something, etc. So if we got to a point where it was 2 is greater than or equal to x, well, we flip it around and say, well, x is less than or equal to 2. Okay, so we've got to change the direction of the sign if we flip it around. Okay. as we said, this bit's super important. We have to reverse the inequality sign if we multiply or divide by a negative number. That's our only extra rule that we've got. Okay, so we've got our first working example here. Okay, so we have writing inequalities from a number line. So we look here, okay, and go, okay, what's our starting point? So we've got our number 2, our variable that we're using is x, okay, and we can see we're to the right of our value of 2, so x is going to be bigger than it. And we need to decide, do I need to include 2 or not include 2? Well, our dot's not colored in, so we're not including it, so we are done at that point. Okay. For B, slightly different. We're between two values. So again, our variable is x. Okay, I'm between this value of -3 and 0. So I'm going ahead, go ahead and write some of this out. So we know x is going to be greater than -3 and less than 0. So we're going to be between those two values. And again, we just need to decide, am I allowed to include either of these values? Well, we've got an open dot on 0, so we're not allowed to include that one. But we have a closed dot on -3, so we are allowed to include it. So we need to put our little line underneath to indicate that we are greater than or equal to -3 and less than 0. So we're between those two values. Okay, so our next slide here is your ones that you can do. Okay, so you can pause now and have a go at those. Now, I'm assuming you've had a crack at those now. So we can see our first one is x is less than 2 and x is greater than -4 and less than or equal to 1. Okay, our next one here, we need to solve our equation here. Okay, our inequalities, sorry, I should say, not our equation, our inequalities. So we do exactly the same process. Now, like our linear equations, we can do it in different ways. For these ones, I'm just going to show you the most efficient way. Okay, so our first step is to take away 4 from both sides because we had +4. They're going to cancel out. I'm going to be left with 3x is greater than 9. I'm going to divide by 3, divide by 3. X is on the right side of my equal sign, as in it's on the left where I want it to be. 9 divided by 3 is 3. So I don't need to switch anything around. I don't need to change the direction of the sign. It's exactly like we would normally do. Okay. For our next one, okay, we have 4 take x divided by 3 is less than or equal to 6. Okay, I'm going to start by getting rid of my 4 here. Okay, I'm going to do that by taking it away from both sides. Okay, that will cancel out there. I'm left with negative x on 3 is less than or equal to 2. Now I've got negative x on 3, so I'm going to multiply. I'm going to multiply by -3 to both sides. Okay, these ones are going to cancel out, so I'm left with my x. Okay, now I've multiplied by a negative, so my sign needs to change. So x is going to be greater than or equal to, and 2 times -3 is -6. So same process, the only thing we need to remember to do is switch the direction of those signs there. Okay, next one here, we've got a little bit going on. Okay, so I've got x's on both sides of my inequality. Okay, so what I'm going to do is I'm going to get my x's on the same side. Now remember, we want to stick with positives where we can, so I'm going to take away this 3x from both sides. Okay, these are going to cancel out, that's the whole point. I'm left with 2 on this side is greater than 6x take 3x is 3x minus 4. Okay, now I'm going to add my 4 to both sides. So I'm 6 is greater than or equal to 3x. I'm going to divide by 3. So I've got 2 is greater than x. So they're going to cancel out. Right, now I've got it written around the wrong way, so I want to fix it up. So then I've got to switch my sign. So I'm going to say x is less than 2. And if you look here, x was on the less than side, okay, over here. So I'm going to make sure when I write it in my correct form, like I've got here, that x is still on the less than side. Okay, so again, our next slide is going to be you having a go at it. Oh, sorry, I didn't actually write these on number lines, okay? But when you see here, I missed that last part, represent our solution on our number line. Okay, so our first one here, we had x is greater than 3, like they had. Okay, and to represent that, we put our open dot, because we're not including 3, okay, just above 3 here, and we're greater than, so our arrow is going to go to the right. Our second one, we are including -6. Okay, so I've got my closed dot above -6, and because I'm greater than, I'm going to the right. Okay, and my last one is x is less than 2. Okay, so I've got my open dot at 2 because I'm not allowed to include it, and my arrow pointing to the left because we are less than 2. Okay. So now it's your turn for this. Okay, so I've mucked that up on my PowerPoint here, and that you couldn't see all of them there. Okay, give them a go, see how you go. Sorry that the answers have already popped up there, but give that a whirl, see how you get on. Okay, and our last parts, okay, usually we do these recap questions together in class, okay, but what do we have to remember when multiplying or dividing by a negative? Well, we need to remember to switch the direction of our inequality sign, okay. What else changes when solving inequalities? Absolutely nothing. Our rules are the same. We just had that new extra one, and our guidelines are exactly the same. So there's no need to try to make things more complicated or anything like that. It's our same process. Okay. So look, hopefully you'll be okay with these ones, okay, and you have a crack at your questions as per your work planner.